Right now, tonight, there is a star in the sky that you cannot see. Not because it's too far, not because it's too dim, but because it sits low in the southern sky, hidden from view for most of the northern hemisphere. Its name is Proxima Centauri, and it is, of all the stars scattered across the entire universe, the closest one to our sun. And still, if you left tonight, traveling in the fastest machine humanity has ever built, it would take you longer than all of recorded history has existed just to arrive. Tonight, we are going to make that journey anyway. Not with rockets, not with fuel, just with imagination and a little bit of physics, drifting slowly toward the nearest star beyond our own, 4.24 light years away, until sleep catches up with you somewhere along the way. You don't need to remember any of the numbers. You don't need to hold onto a single fact. Just let the journey carry you, the way starlight carries itself across the dark, patient and unhurried, arriving eventually, without ever needing to rush. Let's begin. To understand how far away Proxima Centauri really is, we have to first understand how fast light travels, because light is the fastest thing in the entire universe. Nothing outraces it. Not rockets, not radio waves, nothing. Light travels so quickly that in a single second, it could circle the entire Earth almost 8 times. In the time it takes you to blink, light has already traveled thousands of miles. It reaches our eyes from the sun in about 8 minutes. The sunlight warming your skin on a summer afternoon left the sun's surface 8 minutes earlier, crossing 93 million miles of empty space to reach you. Now imagine that same light, instead of stopping at Earth, continuing on. Past Mars, past Jupiter, past the icy edges of our solar system, where Pluto drifts in near darkness. Past the outer boundary, where the sun's influence finally fades into the vast emptiness between stars. It keeps going, and going, for 4 years, and 2 months, and roughly 9 more days. That is how long it takes light, the fastest thing that exists, to travel from our sun to Proxima Centauri. We call that distance a light year, and Proxima Centauri sits 4.24 of them away. You can rest in that number for a moment. 4 years of travel at the speed of light, just to cross the gap between our star and the very next one. Proxima Centauri does not travel alone. It belongs to a small family of stars, 3 in total, orbiting one another slowly, bound together by gravity across vast distances, the way the moon is bound to Earth, only on a far grander scale. The 2 larger members of this family are called Alpha Centauri A and Alpha Centauri B, a pair of stars remarkably similar to our own sun, orbiting each other in a slow, graceful dance that takes about 80 years to complete. If you stood on a hypothetical planet orbiting one of them, you might see 2 suns in the sky, rising and setting at different times, casting 2 sets of shadows, blending together into a warm, double light unlike anything Earth has ever known. Proxima Centauri drifts much farther out, circling this larger pair from a great distance, taking somewhere in the range of 500,000 years to complete a single orbit around its 2 larger companions. It is a small, faint, red dwarf star, easy to overlook, and in fact, it wasn't discovered until 1915, when a Scottish astronomer named Robert Inness noticed it while studying photographic plates from an observatory in South Africa. He gave it the name Proxima, from the Latin word for nearest, because even then, before we fully understood the scale of the galaxy, it was already clear that this small, dim star held a special distinction. Closest, nearest of all the countless stars scattered across the night sky. It is humbling, in a way, to think that the star closest to our entire solar system was only identified a little over a century ago. For all of human history before that, for every civilization, every culture, every person who ever looked up and wondered about the nearest star beyond our sun, the answer remained unknown. We simply didn't have the instruments yet to notice something so faint, so quietly hiding in the southern sky. Now let's think about us. It's not light, but us. Slow, fragile, wonderful creatures who have only just learned to leave our own planet. The fastest spacecraft humanity has ever built is called the Parker Solar Probe, a small robotic craft designed to fly close to the sun, moving at speeds that would make a bullet look as though it were standing still. At its fastest, it travels at nearly 430,000 miles per hour. That sounds impossibly fast. And it is by any human measure. If you could travel to work at that speed, you could circle the entire planet in a matter of minutes. But space is not a commute. Space is almost incomprehensibly vast. And even at 430,000 miles per hour, the fastest speed any human object has ever achieved, the journey to Proxima Centauri would take a little over 6,600 years. 6,600 years. Longer than the pyramids of Egypt have stood. Longer than written history itself. If a spacecraft like that had launched at the very dawn of human civilization, it still wouldn't have arrived by tonight. You don't need to hold onto that number either. Just notice the feeling of it. The vastness, the patience the universe seems to require of anyone who wishes to cross it. So how, then, might we actually go? Not today, not with today's technology, but someday if we ever truly tried. Scientists and engineers have spent decades imagining what such a journey might require. One idea, called a generation ship, imagines a vessel large enough to be its own small world. Farms growing food under artificial light. Families living, working, growing old, and passing the mission on to their children, and their children's children across many human generations, until finally, centuries later, descendants who never knew Earth might arrive at a star their ancestors only dreamed of. Imagine being born on such a ship. Imagine your entire life, every friendship, every quiet morning, every ordinary Tuesday, spent inside a vessel drifting silently through the dark, older starlight ahead of you, the light of Proxima Centauri, slowly growing brighter, year after year, decade after decade, as your ship crept closer. You might never see the destination yourself. Your children might not either. But somewhere, generations down the line, a descendant of yours might step outside, onto a new and unfamiliar world, orbiting a small, dim, red star, and think quietly of the people long gone who began the journey. Before we imagine sails and generation ships, it's worth resting for a moment on the simpler question. What would actually push such a ship forward, across all that distance, for all that time? Ordinary rocket fuel, the kind that lifts astronauts into orbit today, would never be enough. It burns quickly and runs out long before any meaningful fraction of the journey is complete. So scientists have imagined other possibilities, each stranger than the last. One idea, studied seriously by physicists decades ago, was called Project Orion. The proposal, almost unbelievable in hindsight, involved detonating a series of small nuclear explosions behind a spacecraft, each blast pushing the ship forward in controlled, rhythmic pulses, like a series of gentle, powerful shoves from behind. In theory, such a ship could reach speeds far beyond anything chemical rockets allow. In practice, the idea was set aside, for reasons that likely don't need much explaining. A gentler idea involves nuclear fusion, the same process that powers the sun itself. If we could build engines that fused hydrogen into helium, releasing tremendous energy in a slow, controlled, continuous burn, A ship might accelerate steadily for years at a time, slowly building toward a meaningful fraction of light speed. We don't yet have this technology, but the physics, unlike science fiction, is grounded in real, known processes. It is a matter of engineering, patience, and time, rather than a leap into the impossible. And then there is antimatter, the strangest idea of all. When matter meets antimatter, the two annihilate each other completely, converting their entire mass into pure energy, more efficiently than any other reaction known to physics. A spacecraft powered by even a small amount of antimatter could, in theory, reach speeds nothing else could match. The difficulty lies simply in producing and storing antimatter at any meaningful scale, something far beyond our current abilities, existing today only in tiny, fleeting amounts inside particle accelerators. Each of these ideas remains, for now, theoretical. Sketches on paper, equations in physics journals, awaiting engineering breakthroughs that may take decades or centuries to arrive. But none of them break the laws of physics as we understand them. They simply await patience, ingenuity, and time. There is another idea, stranger and more delicate. Instead of massive ships carrying human passengers, some scientists have proposed sending something almost impossibly small and light. A tiny probe, no heavier than a smartphone, attached to a sail thinner than a soap bubble. The idea is called breakthrough starshot. The concept, build a sail so thin, so light, that a powerful beam of light from Earth, focused through a vast array of lasers, could push against it, the way wind fills the sail of a ship at sea. It's not wind this time. Light itself. Photons pressing gently but continuously against the sail, accelerating it faster and faster, until it reached perhaps 20% of the speed of light. At that speed, the journey to Proxima Centauri would take only about 20 years. Not thousands, not generations, just 2 decades. Long enough for a child born the day such a probe launched to be fully grown by the time it arrived. Long enough for someone to remember its departure and still be alive to see its data return. The probe itself would be almost impossibly delicate. A wafer of silicon and circuitry, thinner than paper, wrapped around a reflective sail. It would carry a tiny camera, tiny sensors, enough power to send a faint signal back across the vastness of space, whispering to us, faintly, from 4.24 light-years away, sometime around 20 years after that whisper first left its tiny transmitter. That signal, faint and small, would still take another 4 years to reach us, even traveling at the speed of light. 20 years to arrive at the star. 4 more years for the news to reach home. Let your breathing settle for a moment. There's no need to hurry through any of this. Just let the scale of it wash over you slowly, the way a tide comes in, gently, persistently, without urgency. Let's imagine now what such a probe might actually find, if it ever made that impossible journey. Proxima Centauri itself is a small, dim, red star, a type astronomers call a red dwarf. Much smaller than our own sun, much cooler, glowing a deep, quiet red rather than the bright yellow-white light we are used to. If you stood on a planet orbiting it, the light would feel different. Softer, dimmer, a permanent deep twilight, even at midday. And remarkably, there is a planet there. Astronomers have found evidence of a world called Proxima Centauri b, orbiting closely around that small red star, sitting, by some calculations, within the star's habitable zone, that narrow, delicate band where liquid water might exist. We don't know, not yet, whether that world has oceans, whether it has an atmosphere thick enough to hold warmth, or thin and stripped away by the star's occasional flares. We don't know if it's a barren rock or something quietly, remarkably alive. But it's there. A small blue or grey or red world, we don't yet know which, circling a dim star, 4.24 light-years from the room you're resting in right now. Sometimes at night, when the sky is truly dark, far from city lights, you might look toward the southern sky and see the constellation Centauri, and somewhere within it, though too faint for most eyes to pick out individually, the light of Proxima Centauri traveling toward you, having left its small red star 4 years earlier, crossing the emptiness between the stars, arriving finally, quietly, in your eye, completing a journey longer than any conscious effort you'll make today. That light doesn't know it's being seen. It doesn't know it took 4 years to arrive, or that it began its journey before whatever news event, or birthday, or ordinary evening happened 4 years ago in your own life. It simply traveled, patiently, the way light always does, until it found you. We are, all of us, constantly being touched by old light. Starlight from stars that may have already changed, or dimmed, or in some far rarer cases, no longer even exist, still arriving, faithfully, keeping its ancient appointment with our eyes. You don't have to remember the distances. You don't have to hold onto the numbers, the years, the impossible scale of it all. Just notice, quietly, how strange and beautiful it is that we've even thought to ask the question. That creatures as small and brief as us, living for less than a century, have looked toward a star 4 years away at the speed of light and dared to wonder what it would take to go there. We may never make that journey ourselves. You and I, resting here tonight, will likely never see whether Proxima Centauri beholds oceans, or life, or simply silence. That answer may belong to people not yet born, generations from now, standing on the shoulders of ideas we're only just beginning to imagine. But the wondering itself is its own kind of journey. Tonight, lying here, your mind has crossed 4.24 light-years without moving an inch. You've imagined generation ships and laser-driven sails thinner than soap bubbles, and a small dim red star with a quiet planet circling patiently around it. That is enough for one night. Let yourself rest now here on this small, warm blue planet, circling an ordinary yellow star in an unremarkable corner of an ordinary galaxy. 4.24 light-years away, another star waits patiently, the way it has waited for billions of years already, and will likely wait for billions more. There is no need to reach it tonight. There is no need to solve anything, or decide anything, or figure anything out before sleep arrives. The stars will still be there tomorrow. Proxima Centauri will still be waiting, quietly, faithfully, exactly where it has always been. For now, only rest. Let your breathing slow. Let your thoughts drift outward, gently, the way starlight drifts across the dark, unhurried, patient, arriving eventually, without ever needing to hurry. You are stardust, resting quietly on a small world, beneath an old and patient sky. Rest now. The stars will keep watch until morning,